This was an interactive challenge. I lost in the buildings, then I could not use my card at the machine, but finally the strongest survived. I have coffee and some coke. Okay, I have a question for you. Mathematics. So, are you familiar in derivation, integration? What about differential equations?
Yes, that's
You
next.
get?
That's next.
Yes. Do you know algebra? Sorry?
Not yet.
Not yet. Not yet. So you don't know what is matrix and
You just started.
you just start. You don't know what is algebra. Okay, doesn't matter. What about probability theory? Do you know what is distribution function? You learned, but you have seen, you haven't learned, because probability function is not in secondary school.
No, I did in the first year. But we will also give the same in mathematics to this semester. We will also do it in mathematics to this semester.
Okay. Without these mathematical effects, there is not so much sense to teach you physics, because I just can repeat the secondary school, more or less. Or this 3 different fields of physics in one subject, that's a very weird approach to me. Okay, so let's calculate what happens. Now it's better than, because I have only one topic to give you per lecture, and then we have more time for calculation or anything. Okay, practice for today. Yes, so we have something from the last lecture and something from now. Okay. Last? Yeah. Okay. I know, because I'm sitting here. Last time we had this task. We had the steel stuff with the diameter, and we had an aluminum ring with a smaller inner diameter, and we heated only the aluminum ring, and we got a good result. That was the first method. And the second method is heating both them. So just for fun, I do the second solution, the second way. And then we continue with other very nice exercises. Okay. I also figured out how to switch off the sugar. Good. What I have. So we have actually the steel is not FR, it's much more difficult, but that's okay. And yeah. No. Actually, from the text, what temperature should the ring be heated on? So it says I have to heat only the ring. Doesn't matter, I will heat both them. And then this is only for misguided, this coefficient. So, this temperature is the question, and it means that the DAL should be the aluminum ring's diameter should be the diameter of this shaft. So this what we should achieve. We had done last time, so this is the second solution. It means the following. here. So the diameter of aluminum should be diameter of iron, I mean steel, means that it's not derivate, it's just other quantity. The delta T is the temperature increasement. Okay, so we need delta T, and when I have delta T, it's not the solution because I have to add for this. So this T2 is T1 is delta T. Okay, what we have? We have which is larger, the aluminum was smaller. Okay, so ow! So ow. Ow. These jokes are horrible, but they are working. Always. Depends, not always working. Okay, so this was the result will be Kelvin, so perhaps it's not a stupid mess. Okay, 160 Kelvin. Or Celsius, doesn't matter. So it was something 20 Celsius. So it's that's the result. I cannot check it, but I can do something else. Come here. So last time the solution was 100. No, the solution was this 93. Altogether 113 Celsius. This time we heated only the aluminum ring. When we heat the steel shaft, then we need higher temperature. So it's a stupidness. Actually, we could have guess what temperature for the text. What temperature should the ring be heated to? That was actually the exercise, the problem. So the first version. And in the practice, when you are a mechaniker or you have such a problem, you just heat the ring and not everything. Okay, that's okay? Okay. It's actually a simple problem without advanced mathematics. It's very difficult to give you more difficult task actually. But be happy, I think you have other business to do as well. Okay, so now we can switch to the material of this and last lecture. The atmospheric balloon floating at an altitude of several kilometers, that's funny, has a volume of 800 cubic meters. The temperature and pressure of the helium inside it are the same as the surrounding minus 50 Celsius and this very small pressure. It's very small, it's 1/20 of the surface. How many moles of helium are in the balloon? What is the mass of the helium gas? What is the volume of the balloon at the time of launch of the Earth? If the gas inside the balloon was characterized by 0 Celsius and 1 atmospheric pressure. Well, it's funny. The helium has 2 neutrons and 2 protons in its core. It has 2 electrons, so it's a very stable noble gas. But there are other helium, when you have 2 proton and 1 neutron, it's helium-free. It's easier to do fusion with that one. And they say the moon is full of helium-free. It comes from the solar. Have you ever seen the Iron Sky? It's a Finnish low-cost trash movie. No? It's funny. It's started with collecting helium-free, and It's typical Finnish humor. The Nazis survived the Second World War on the other side of the moon, and they built helium-free engines everywhere. And someone, the American president, she looks like Susan Baldwin, sent a mission to the moon. And they have an iPhone, and finally they can start the invasion of the Earth using the iPhone. It's a trash movie. It's funny actually. But this is a good stuff, good exercise, interesting, I think. If not, I will make it more interesting. Okay, you are familiar that the balloons are floating. You know what is floating. Floating is okay. So you have to push enough liquid or gas to gain force which points upward. Okay, so have you seen such thing, meteorological balloons, launch of meteorological balloons? It's there is meteorological balloons, hobby balloons, and also real serious scientific experiments. You have something. You have a payload, and you put some, usually it's not helium, but it's hydrogen, helium in it. It is on the surface. Then they reach 30, 40 kilometers altitude. Then this balloon is broken because of the inner pressure, and then the payload fails with the parachute. The distance could be few hundred kilometers, and it's very, very interesting. I have friends, and also I have a TDK student, not mine, but I corrected the thesis, that had this payload. You have a camera, and at 40,000 meters, 40 kilometers, the sky is black, and everything looks like in the space. Do you remember Felix Baumgartner? With the sponsor of Red Bull, he sat in a balloon, he jumped in a scaphandler, and then reached the sound speed during the free fall. He need to do many exercises, because if you start to spin fast, you cannot pull your hands and legs, and you cannot open your parachute. But he went to 40 kilometers. Problem was that after launching, he could not change his mind. There were no way to come back, only with jumping. But jumping for 40 kilometers, it's madness. Here, that's the start. Then you are on the top. Then you have this V1, T1, P1. Here you also have a payload, and you have V2, T2, and also P2. That's huge. The pressure changes if you go up. and also the oxygen level is changes, but doesn't matter. Here we have surface, and is the altitude is not a question. V2 is 800 cubic meters. That's fine. Temperature is -50 Celsius. It's quite warm actually. I'm not kidding. It's better to switch immediately to Kelvin. The pressure
Isn't it 223 Kelvin?
Sorry?
223 Kelvin. Minus 50 degrees.
Thank you. Thank you. Yes, it's start from 30. Thank you. You are listening. Pascal is fine. Okay? What we know that M is okay. We also know okay, so now the questions. How many moles helium are in the balloon? What is the mass of the helium gas? And what was the volume of the balloon at the time of launch on Earth? Okay. We have the task, the exercise program. And you can imagine what is going here. Okay? A. Question is how many helium is there? Okay? What we know, P, so V, pressure, so volume is N, R, T. This is the state equation of the ideal gas. Okay? We have P2, V2. We need the number of helium. R is the constant. T2 we also have. So we just need to calculate this. P2.
Isn't it V2 times V2 divided by R?
Sorry, E.
Isn't it V2 times V2 divided by R times T2?
Thank you. Yes, you are right. I wanted to do the opposite what I wrote. Yes. So it's P2, V2, R, P2. So P2 thank you. V2 okay, it's okay. Do you understand what I have done? I just calculated the units and the result will have no dimension. It does not have what is it, unit, because it's just a number. So what I do is pair of good. This is a self-check. Did you remember remember this from secondary school, or is it something higher? It's called dimension analysis.
High school.
High school. You used it. I also remember I used it in high school. Just I was not a common student, so okay.
We also had it in basics of natural science.
Sorry?
We also had it in basics of natural science.
Okay. You know this.
Yes.
Great. That's great. Oh, so what we have? We have that one, and oh, it's not bad. So it saves approximately so this is it's approximately current 9 kilogram of helium. I just multiplied 4 with 4 grams. This. What is the mass of the helium gas? The molar weight is 4 grams or 0.004 kilograms. So I just multiplied this one. I hope I was not wrong. So it's 4, 28, 2, 8, 1. It's it should be this one. But I can yes. Yeah, I'm right. More or less. Actually, the 3 is better. It's okay? Then, I would need a third board or something like this. Could you?
Yeah.
Okay. Then I erase this bottom. C. The question. What was the volume of the balloon at the time of launch of Earth? So the volume. So you have this for example, or it's easier if you learn only this formula. So P, I mean pressure 1 times volume 1. Okay. Okay, so we know volume, V2, pressure, temperature, we need this one. So it means P2 per, I mean not P, but P2 per P1, and then T1 per T2 times V2. So, we have Oh, that's interesting. But it's okay. So the result is so the extension of the balloon was more than almost 16 times. The pressure dropped, also the temperature dropped, but the pressure dropped more. So that's why we have this result. Do you remember what was our result for the mole number? Okay, that's quite fine. Yes, I remember the mass, and this is also, this is better. So, we are great, we are doing well. Okay. Oh. Can I help you? So, the gas is 1 mole and 1 atomic. will be important. Ow. I hate this. I will calculate this later. Oh, I can do it right now. Why not? Okay. And this means pistol. Questions? Into internal energy change and what is the volume work done by the gas? Okay. Let's start with the temperature. So we have this cool and okay. Insufficient. Okay, so problem is the following. Something is missing from this exercise. One more monoatomic ideal gas. So I need the mass, but there is no mass given. Interesting. Okay. Yes. This is, I have to correct this, are large, capital C's. So this is molar specific heat. And these are also capitals. So, this is capital C right now. And okay, and So, there are different forms of this equation. With molar number, that's the form. I will correct that one because this is not, it's capital C, not small. And we got 1440 Kelvin. That's the new temperature. And this is the end of the practice. We will continue next month. Okay? Thank you very much.